Hello everyone, myself Dr. J. Sandil Kumar, Assistant Professor, Department of Computer Science and Engineering, Kalinga Karnataka Institute of Technology, Coimbatore. Today we're going to see about searching algorithm in artificial intelligence. So what is searching algorithm? For this introductions, search is an core mechanisms for the problems of solving in artificial intelligence. Intelligence agents systematically explore the state space to the identify a sequence of actions that leads to the goal. Such techniques enable the agents to make the rational decisions in complex environments. We have the key applications area such as game playing like chess, tic-tac, path planning, such as GPS, robot navigations. Robotics is motion planning and obstacle avoidance. And expert systems, the decision making. So, what is the purpose of this searching algorithm is? What is search in artificial intelligence? Search is a systematic problem-solving problem process used in artificial intelligence. It involves finding a sequence of actions that leads from the initial state to goal state. Each action causes state transactions, moving the agent closest to the solutions. AI search operates with state space, which represents all possible states of problems, all valid actions between the states. The search process is guided by the problem solving definitions chosen search strategies. The performance criteria such as optimals and efficiencies in searching techniques. The searching algorithms helps AI agent make the decisions when the solution is not directly known. Explore the alternatives systematically. Avoid unnecessary or repeated paths. So these are the purpose of an artificial searching in artificial intelligence. Suppose if we're having any problems, we have to identify the solutions with the help of in problem solving techniques. So that's why we are going for these topics. So as you know that we have the environment, we have the problems in the environment, it will be transferred to the agent. So we had to solve the problems in the agents with the help of in searching techniques, and we had to identify the data, how it is being sorted or in searching with the help of this problem searching techniques. So here you can see that we have this initial state here, that the initial state is like an that problems is occurred. The state space, we have so much of problem solving techniques, that is in A, state B and state D, and we have the state for C here. So all the possible solutions, we have some problem solving techniques. So here, what is the sequence of an action is find a series of steps from start date to goal through the valid actions. State space represents all the possible states of the problem. Search algorithms guides the agents to explore and determine the best path. So with the help of these techniques, we will be solving the problems in the environment with the help of an agent. Search is the process of defining a sequence of actions that solves the problems. It transforms the initial state into a goal state through the valid actions. AI search operates with the state space and set of all possibles. So this is we are calling a search in artificial intelligence. So next we are going to see about problem solving methods. We have that problem solving methods. What is problem solving methods? The method of solving a problem through AI involves the process of defining the search space, uh, deciding state and goal states, finds a path from the states to goal state through the search space. The moment from start state to goal state is guided by the set of rules, especially designed for the particular problems. What is problem here? It is a question which is to be solved. For solving a problem is needed specially defined. The definitions means the defining the state, start state and goal state, whether the valid state and transactions. The finding the solutions after a representation of the problem, the related knowledge in the suitable format, the appropriate methodology is chosen, which use the knowledge and transform the state to goal state. The techniques of finding the goals solutions are called search techniques. The various search techniques are developed for this purpose. The representation of an AI problems can be converted into following four parts. One is an lexical part, structural part, procedural part, and systematic part. What is in lexical part? That determines which symbols are allowed in representation of a problem. Like a normal meaning of lexicon, there is an abstract called fundamental features of the problem. Structural part that describes the constraints on the how the symbols can be arranged. This corresponded to the finding out the possibilities required for joining these symbols and generating the high structural unit. Procedural part, that specifies access procedures that enables to create a descriptions, to modify them, to answer the questions using them, and semantic part that enables that establish a way of associating the meanings with the description. With the help of the representation of AI problems in the searching techniques to solve the problems, we have this kind because that problems can have to be had to solve with the help of an splitting like this. In this part, I had to make this in symbols format for the understanding purposes, and then I can solve with the help of this part of the solving techniques. So what we here we are going to see about the problems and solutions within the form of well-defined structures. So to see these structures, we can go for this part. Yeah, the problem formulation in AI such as we have four initial state, and that is starting point of the agent, actions, all the possible moves available to the agents in a given state, and transaction models defines the result of applying an action to a state. Then goal test determines whether the current state is goal test state. Path cost measure the cost of reaching a state from initial state to initial state. So, with the help of this definition of this problems formulation in AI, we can see that the initial state and actions, a description of possible actions available to the agent, the descriptions of what actions and thus the formal name of an translation models specified by the functions results. That is, there is a S is an state and A is an actions. The return the states of the result of successor doing the actions in S states. We also use this the term successor to refer the any states. So this kind of an descriptions can in the form of an transaction models. We have the goal test. So whether I have reached my goal state or not, with the help of an human being statistications, and how a path, the functions, cost path functions that assign the numeric cost to each path. The problem solving agents choose a cost functions and reflects its own performance measures. So these are some examples for the searching problems and solving problems with the help of an AI problems. Tic tac toe, 8 queen problems, chess problems, a tower of honey, traveling salesman problems, monkey and banana problems, crypt arithmetic problems, and block world problems. So this with the help of these problems, we and the machines can be trained. Then we can go for this solving the problems. Okay. So here we can see that already we have seen this part. Next, we are going to see about state space search representation. The concept called state space is completely set of all possible states that can be reached from the initial state. It defines the problem environments in which the search algorithms operates. Representations, we have the node edges like an tree and graph. Node representations in the state of problems. Edge represents the actions or transactions. Transitions between states. The solution of the path is from the initial node to the goal state. So the example of the state representation is 8 puzzle problems, maze navigations, and route planning. So these are some example of a state space representation. So really, what is this state space? Is we have the all possible states is referred. We are going to see about search trees and state space graph. So with the help of search trees, the searches generated dynamically during the search process. Each node represents the state reaches by the particular path. The same state may appear multiple times through the different path. The science depends upon the search algorithm used. State space search graph. Here, the state space graph represents the entire problem search. Each node corresponding a unique state. Connections of the connections representations of all possible actions exist independently of the search process. Avoiding repeated states, repeated increases time and memory complexities. So closed list is used to store the already visited state. Presented revisiting the same state, improve the search efficiency. So with the help of this search tree and state space search graph, we can solve the problems and we can visit whether the problem solved with the help of a tree structure format. Next, we are going to see about the classification of search. So the very important thing is the classification of search algorithm. So how it is classified? Our AI search algorithms are classified based on the amount of information available about the goal state and the nature of the problem's environment. We have what does this means? That we have some informations. So if we having any informations about the goal state or an data, then it can, if you have means it is called as informed search. If you don't have any information, then it is considered as an uninformed search. So searching techniques we have split it into two part. Okay, we'll see that. Like an Yeah. So we have the searching techniques is split into two part. One is an informed search and informed search and uninformed search. In uninformed search, we have BFS, uniform cost search, depth first search, depth limited search, iterative deepening depth first search, and bidirectional search. In informed search, we have the best first search and ASR algorithm, ASR search. So what is this? And we are going to see about this uninformed search. In no additional knowledge about the goal locations, use only the problem definitions, explores the state space systematically. The example is we have that BFS, DFS, and uniform cost. Next, we are going to see about the informed search. We have the heuristic informations to guide the search. Estimates how the close state is to be to the close, most efficient than the uninformed search. Then example is we have this best for search and ASR algorithm. With the help of this state as uniform and informed search and uninformed search, so we'll solve the problems also. So the classification of search algorithms continues like an local search algorithm and adversarial search algorithm like in game planning playing. So what is local search algorithm? Operates on a single state, single current state, does not maintain a full search tree suitable for optimization algorithms. Example has hill climbing, simulated annealing, and genetic algorithms. In adversarial search, we have involves the multiple agents with an conflicting goals used in the competitive environments. Focus on maximizing one advantages while minimizing the opponents. Example: minimax algorithm and alpha beta pure. So these two algorithms will be seen in later. And now we are going to see about only the informed search and the uninformed search in this video. Yeah. What is informed uninformed search? It is otherwise called as blind search. So as you know that if you don't have any information, it is considered as an uninformed search. So here the definition is there is a class of search algorithm that does not use any additional information about the goal states. The search algorithms guide us only by the problem definitions, successor functions, goal test, and path cost. The key factors of the uninformed search is no heuristic function is information is used. Explore the state space and systematically may examine the many unnecessary states. The guarantee solutions only for the certain algorithms. So these we are calling as uninformed search. So as I told, this is the differentiation of an searching algorithm. Now you can see the types of an algorithm: BFS, DFS, DLS, IDDFS, and uniform causes. Other one is we are calling as bidirectional search. So these are the different types of searches algorithm in the search. It's uninformed search algorithm. First one, we are going to see about it, burst first search algorithm. So what is burst first search? It is in start state and we have the goal state or let us consider this is an goal state. So how it is transferred? It will be going from the left node and the right node. Then it is be goes to the C node, D, G, H. Then it will start from E, F and I. So and then it will go to the K. So this one we are calling as depth first search. So depth first search is similar like an the depth of this path. Okay, the concept expands the Solos node first, explore all the nodes at one depth before moving to the next state. Next step, use this as FIFO, so it will be used as a FIFO queue. um, BFS algorithm steps are insert the initial state into the queue, remove the first node from the queue, expand the node and generate a successor, add unexplored successor to the queue, repeat until the goal is found. What are the properties of the BFS are the complete, yes, it will be completed, and optimals, yes, time complexity, order of B power D, state space, order of B power D. So what is it? B is and branch factors and D is and depth of the solutions. So what is the application? Shortest path algorithm, level order explorations, and small state space. So this one we are calling as BFS. Next we are going to see about DFS. What is DFS? So you can see that first it will go to the A, then B, then D, then E, A, C, G. So it will go in the form of depth oriented in the structure. Okay. So the concept is expand the deepest node first, explore one branch fully before backtracking. Use a stack or recursions. BFS algorithm steps. First, start from the initial state, expand one successor deeply, backtrack when no successor exists, continues until the goal is found. So this one is the steps for the these are steps for the DFS algorithm. Next in the properties, the complete, yes, no, it will not complete because it is an in-depth of an space. Optimals, we have the no here. Time complexity is order of b power m, and state space complexity is the order of b power m. So what is the M is an maximum depth. So if it is having large number of an goal, then it will go there. It will be avoided in the areas. So what is the advantages and limitations? Advantages: low memory usages, simple to implement. What is the limitations? May stuck in the infinite loop, not guaranteed to find the optimal solutions. So this is the DFS algorithms. Next, we are going to see about depth limit search. As you know that we have some disadvantages in this DFS, we have to solve with the help of a depth limit search. What is it? We will be setting the limit and we will be checking the whether the goals is reached or not. The concept is DFS is with a predefined depth limit prevents the infinite depth problems. So DLS is properties we have the only if the solution depth is limited. Optimal is no when use this when the maximum depth is known. So this is the DLS. So we have to find identify the we have to say we are going to set the level 2. If I'm setting the level 2, up to that only it will be search. It will not go to the next levels, right? This one we are calling as DLS. Next, iterative deepening depth search for search is the concept is combine the advantages of BFS and DFS. Performance BFS repeatedly with an increasing a depth limit. So DLS, it will be setting of limit here. So you can see that limit of is 3. Note that the iterations depending is limit is 2. So first limit is iteration is 0. 0 positions we have A, 1 position we have A B and B C. So you can see that goal is reached in this position. If you want, we can go to the next stage because we have some combinations advantages of BFS and DFS in iterative deepening the depth for such algorithms. Next, we have to see about uniform cost search. Here, we are going to see about the low cost path. Okay, so if we have, which I have some left and right, we have some limited. Okay, one is here and 4 is here. This is the lowest value. I am going to this A. Next, use the priority queue generalization of BFS. So with the help of this, I can identify the goal search in the minimum cost. The uniform cost search is properties complete yes, optimal yes, time complexity depends upon the cost functions. So with the help of the cost functions, that depends upon the cost functions, it will be working on. Next, we are going to see about bidirectional search. Here, the root node and we have the goal node. So it will be search with the help of and forward search, and it will be help in the form of an backward search. So with the help of this searching techniques, easily I can search both the side at a time. So how it is work? The bidirectional search performs two simulation search, one forward search from the initial state, one goal backward from the goal state. The search stops when the two search meets in the middle. Okay. The working principle: start search from the initial state, start search another search from the goal state, expand the node alternatively from both sides, stop when the common state is found. Futures reduce the effective search depth faster than unidirectional search. Requires the goal state to the explicitly known. What is the properties? Complete is yes, optimal is yes, time to complexity, order of b power d by 2, and space complexity is order of b power d by 2. Okay, so these are the different types of an uninformed search. Okay, hope you have understand this. What is the comparisons of this? As you know that optimals and completeness, then times and spaces we have seen in this algorithm. Next, we are going to see about that informed search. That is, we are calling as heuristic search here. Yeah, the heuristic search. So in the informed search has an search has used the additional problem specific knowledge to guide the search process. This knowledge is represented using a heuristic functions, which estimates how close a state is to be the goal. Functions is considered in the h of n. The heuristic function h of n estimates the goal's cost from the current state and n to the goal. It helps the algorithm choose the most promising path. Heuristics are usually an problem dependent, approximate, efficient to compute. So example is h of n is a straight line distance to the destinations. Why informed search is faster? Reduce the number of explored nodes, avoids unnecessary avoid unnecessary path, direct the search towards the goal, improves the times and space efficiently compared to the blind search. So here we have the two types of searching in the form of informed search. We have an best first search, greedy best first search, and A-star algorithms. Right? We are going to see about the BFS. So in BFS we have this evaluation searching techniques. F of n is equal to h of n, where h of n is then heuristic estimates of the distance to the goal. Then what is BFS? So, is an informed search strategies expand the most promising first node. Node selection is based on the evaluation functions. The working principle: insert the initial state in the priority queue, select the node with the lowest heuristic values, expand it, and add a successor to the queue until the repeat the goal is found. So here the general compiler is no, optimal is no, fast yes. So it will be quickly fast. Advantages: explore a few nodes, efficient for the large state space, simple heuristics based guidance. Limitations: may stuck in local minima, depends heavily on the heuristic quality, no guarantee of the optimal solutions. So this one we are calling as best for search. So we go with this one we are calling as an algorithm for the BFS. Before that we will see that problems. Here we have the h of n and we have the values. Okay, I have to compare, I have to start from the open a comma b. So from the starting node I can go a as well as b. So that is the open a comma b. Now I am closing this s value here. So I'm opening a because I have to open a because it is in lowest value here. uh, I have to make as, so okay, b is the lowest value and a 12 is the a is a maximum value. So I have to open a, close s comma b. I have to go to the b here. Okay, I have to go to the b here. Next I am going to from b I can go to e as well as f. So here what I have to do, I have to close ea and close this minimum path is 2 here. So I'm going to the 4 2. So f I have reached here. Now I have to open here and I have to check here. My goal is reached. Okay, my goal is reached here in this directions: 13, 4, 12, 0. So what is the value? 17. Total 19 values I have reached my goal stage. This one calling as BFS. So this is the algorithm what I described here. I have to in this we can identify the solutions. So what is the advantages? Best for search, you can switch between BFS and DFS by gaining the advantages of both algorithm. This algorithm is more efficient than BFS and DFS. Disadvantages may become the unguided depth first search. In the worst case scenario, it can stuck loop of the DFS. This algorithm is not optimal. Next, we are going for an heuristic functions. As you know, that is and is denoted by h of n. It's called as estimate cost of the cheapest path from the node n to the goal state. Heuristic functions are most common from in which an additional algorithm knowledge in the impact to the such algorithm. Okay, right. So we have seen this. Next, we are going to see about A-star algorithms. So what is A-star algorithms? With the help of these formulas, f of n is equal to g of n plus h of n. So g of n is an cost stretch node and from the start. Here h of n is the cost reach from node to the goal state. It is in start state and it is in goal state. So let us see some example. Then we'll go for the definitions. Okay. Yeah, you can see that values. So first we can see the h of n and you can see the g of n. Okay, so let us consider from static state to the goal state. I have to reach the goal state. So you can see from yes I can go a as well as g. So I have to find the values. So first f of n is equal to g of n plus h of n. What is g of n? Is the value is 1 here and h of n value is here. We can see the a value is 3. So the total add 1 plus 3 is 4. Here you can see the g, it is in 0 here and the value is 10 here. In this values we can see the 10. So 10 plus 0 is equal to 10. Okay. So here the minimum value is 4. So I had to choose this path. I had to hold the values here. Next I am moving from a s to a. So in a we can go to b as well as C. So the values you can see that we can have to calculate. Before that, you have to check S2 A. Okay, yeah, from 1 2. So that's why I have marked as 3 here. Okay, g of n is equal to 1 and 2. So 3 values. B is 4. Okay, so 3 plus 4 equal to 7. Again, you can see S A C. So here 1 2. So 2 is here. So 2 plus 2. So this 2. Okay, so this is 2. So answer is 4. I have to choose this path. So yes, A C. Okay, finally you can see the values calculated. Okay, I have reached the states S A C G. Okay, f of n equal to 6. If I have to find yes a 6 and this 10, because I have reached the goal in the form of a 10 here, but I have reached the goal in the form of a 6 here. So if it is less than here, if suppose if the value is 5 here, I have to choose this value in the states. So this is the minimum cost I have reached. So my state is S A C G. So this one you are calling is A star search algorithm. Okay. This is a algorithm for this problem, and we can see the advantages. It is the best algorithm than other such algorithms. This it is an optimal and complete. It can solve very complex problems. Disadvantages: it does not always produce the shortest path. It is not practical for various large scale problems. So these are the different types of an informed search algorithms, right? So you can see the algorithms. So you have to learn this algorithm for the stats. Okay, right? Thank you. Thanks for listening. Like my videos, share the videos, and subscribe my channels. Thank you.